Have you ever wondered how you could solve problems like the world's most famous detective? Well, Sherlock Holmes didn't rely on magic. He used a systematic method, and in this explainer, we're going to break down that method into skills and models that you can start using right away. We'll start with Sherlock's core method of systematic thinking, then get into the specifics of observation and deduction. After that, we'll explore some frameworks for creative thinking, look at a few powerful integrated models, and finally, we'll talk about when to use them. And maybe more importantly, when not to.
This famous line really is the key to his whole approach. It's not about guessing the right answer from the start. It's about a process of elimination, systematically ruling out what's impossible until the only thing left has to be the truth.
So let's start there, with the core idea of systematic thinking. Sherlock Holmes is basically the poster child for this kind of thinking, right? But the most important thing to realize is that his amazing abilities, his sharp observation, his powerful reasoning, they aren't superpowers. They're skills. And any skill, with practice, can be learned.
So let's get into the two core skills, observation and deductive reasoning. Think of these as the two fundamental inputs for solving any kind of problem.
You know, most of us just see things passively. But real observation is totally different. It's an active process. It means you're consciously trying to gather information, to notice the tiny details, because those details are the building blocks for everything that follows. So how do you get better at it? Well, you can start by focusing on these 5 habits. It's about training your brain to see what other people miss, to spot when something is even slightly out of place, and then to connect all those little dots to understand the whole picture. Once you have your observations, you need to use deductive reasoning. This is really the art of working backwards. Instead of just reacting to a problem, the effect, you trace its origins back, step by step, to figure out what actually caused it in the first place. Okay, so how can you do that in a structured way? A really fantastic tool for this is the fishbone diagram. It gives you a clear, visual map to lay out every possible cause of a problem. This helps you separate the real root causes from the more obvious but less important symptoms on the surface. All right, you've analyzed the problem. Now, how do you actually come up with a brilliant solution? This brings us to frameworks for creative ideation. Often, we're taught to think vertically. You know, step by step, very logical, always looking for that one single correct answer. But to find truly innovative solutions, you need lateral thinking. This is all about breaking the rules, challenging your assumptions, and exploring all sorts of possibilities, even the ones that seem a little wild at first. And the Scamper method is an incredible way to practice that lateral thinking. Just think of it like a creativity checklist. It gives you 7 different prompts, 7 questions like, what can I combine? Or what if I did this in reverse? That force you to look at an old problem from a totally new angle. Now, let's pull all of this together and look at a few powerful integrated problem-solving models. The Osborne-Parnes model provides a 6-step path from start to finish. The real genius of this model is how it alternates between divergent thinking, where you're brainstorming and thinking broadly, and convergent thinking, where you're narrowing down and picking the best option. That cycle makes sure you explore every possibility before you commit to a plan. Now, for really high-stakes problems, you've got the astronaut method. This was developed by NASA for situations where, literally, failure is not an option. It's an incredibly rigorous 8-step process that forces you to define the problem with absolute precision, evaluate every single consequence, and be ready to adapt as soon as new data comes in. Okay, so how do you actually apply these models? And maybe more importantly, what are the pitfalls you need to avoid? Let's talk about application and limitations. So why is all this so important? Because these models give you a structured process, something reliable to lean on instead of just your intuition. They force you to dig deep for the real root of a problem, and they dramatically increase your odds of finding a truly novel solution. But it is absolutely critical to remember these are just tools. They're not magic formulas. Their effectiveness depends entirely on the quality of the information you feed them, and they are no substitute for your own expertise in a field. If you stick to them too rigidly, you can get stuck in analysis paralysis, or even worse, ignore a brilliant gut feeling. Ultimately, the most important skill is knowing which tool to use for which job. You wouldn't use NASA's checklist to pick a new color for your website, right? So the real question to leave you with is this: what problem are you facing right now, and which of these methods are you going to use to solve it?